This lesson is on 6-10 in your Savvas book. It's on page 372. So if you could turn to that with me, that would be great. Our objective today is how can you use angle measures to determine whether two triangles are similar. Every lesson it gives you an essential question. That's what you're going to be learning about today. For example 1, determine whether triangles are similar. The problem reads, Justin designs another pair of flags for another model sailboat. The larger flag is 1.5 times the size of the smaller flag. How can Justin determine whether the triangles that represent the flags are similar? So remember, similar is a sequence of rotations, reflections, and translations, and dilations that will map one figure onto the other. So the first step to solving this problem is that they'd like you to draw and label the angles that represent the flags. So what they did is they took these two images and just took the color and pictures off and drew them right next to each other. In the example, it gives you angle C is 50, so we copied that here. Angle B is 46, and then angle R is 46, and angle S is 50. If you notice, there are two angles that are exactly the same. So here's the next step. It says find a sequence of transformations that maps one pair of the congruent triangles to each other. So if you take this triangle and turn it this way and match up the 50 to 50 in angle C, that's really going to be angle S is now over here on top of angle C. So they're matching those triangles. What that does is that creates parallel lines for AB is parallel to QR. Okay? So it says a rotation and translation would map angle S onto angle C. That's what they did here. Angle R and angle B are corresponding angles. So that means this angle, angle R, is equal to angle B because they're in the same location. It also says BC is 1.5 times RS. So in the problem it told us that the larger flag is 1.5 times the size of the smaller flag. So what that is it's a scale factor. So here's the rule that you really want to pay attention to right here, where it says generalize, put a star there. It says if two angles of a triangle are congruent or the same measure to the corresponding angles of another triangle, then the triangles are similar. This is called the angle-angle criterion. This really, guys, the angle-angle criterion, we call that your reason. So sometimes in the text they'll say explain or explain the reason why this is true. This is your reasoning about why it's true. If two angles are congruent, then you can use the angle-angle criterion to say that triangle ABC, this little squiggly right there, means similar. Write that in your notes, please. Is similar to triangle QRS. This is something that you want to start to memorize. You'll use that next year. Let's go ahead down to the try it. The question is triangle XYZ similar to triangle LMN? Okay, what do we know about the sum of angles for a triangle? They first ask us to find the measure of angle X. Well, we know that 92 plus 42 plus angle X is going to equal 180. So what you can do is add 92 plus 42. That would give you 134 plus angle x equals 180. So to find the measure of angle x, you're going to subtract 134 from both sides. Let me try that one more time. 180 minus 134 is 46. So this angle measure for angle x is 46. Now, if you take a look, 46 degrees. If you take a look, we know that 92 and 92, we have that one that matches. 46 does not equal 53. Well, maybe they're flipped. Maybe n is 46, but that would mean that z is 42, and that's not the case. So already I know that these two triangles are not similar, but it wants me to ask, or it's asking me to find the measure for angle n anyway. We can do the exact same process. 92 plus 53 plus angle n is all going to equal 180 degrees. So go ahead and add together 92 plus 53, and that's 145, plus angle n equals 180. So to find angle n, we're going to subtract 145, and angle n measures 180 minus 145 is 35 degrees. So angle n is 35 degrees. So when it says the triangles blank similar, you're going to say are not similar. But you're not done yet, because it says convince me. Now for this one, I had to get a separate piece of paper because I cannot fit my answer and all that. If you write smaller than I do, that's great. Good for you. However, I do not write that tiny. So, in your notes, or if you want to squish, go ahead. This is, whenever I write on my notebook paper, I always put the page number, just so if I need to look back, I know what the heck I'm looking at, okay? Page 372. Convince me. Oops, I can't spell convince. Oh my goodness. So it says, use what you know about transformations and parallel lines to explain why the angle-angle criterion is true. So, in order, here's my answer. In order for angles, oops, oh my goodness, angles to be congruent, the lines must be parallel. In this case, the angle measures are different. Which creates lines that are not parallel. So the angle measures are not equal. And the triangles are not similar. Let's move on to example number 2. on page 373. We're now looking at example number 2. Again, we're going to continue to focus on we need two angles that are equal to each other in measure. That will tell us if the triangles are similar. So just by looking at letter A, it says, are the triangles similar? Explain. Okay? So they said because measure angle M, because angle M is the same measure, congruent, that's what that little symbol means, congruent to A, measure angle A, and P is congruent to C, then this triangle, MNP, this triangle, is similar to, that's what that little squiggly line means, similar to triangle ABC. Okay, that's what all of those markings mean. If you take a look over here, this one has the angle measure of 42 and 45 and 85 and 85. It only has one angle measure that is the same, so it is not similar. Now we're going to go down and try it. It says, knowing that this is a huge piece of information, okay, because if we don't have parallel lines, then we can't use the information from previous lessons about angles to know that they're congruent or not, okay? So this piece of information, super important. QR is parallel to YZ, okay? That means that we have vertical angles right here. So this angle with the blue dot and this angle with the blue dot, those are vertical angles. Vertical angles are congruent, so these equal each other, okay? Then we're going to take a look at the transversal, okay? When you're talking about parallel lines, let me get a different color pen really quick. We know that interior angles, alternate interior angles, are congruent, right? So we can say that, I don't want to use orange. Orange isn't going to show up very well. This angle, angle R, is the alternate angle with angle Y. Do you see how they're, if you look at just this transversal, they're on opposite sides and they're inside the parallel lines. So they're alternate interior angles, okay? So the green ones, angle R, and angle Y are what we call alternate interior. Those are also the same measure. Okay, these are the rules that we learned in the last couple lessons. So now we can say definitively, right, that triangle XYZ is similar to triangle XRQ, I'm sorry, and it says explain, so here's our because of, and let's steal words from the page before, angle, because of the, we should say because of the angle criterion. It's not enough to say that though. You have to say that both angle X's, are congruent because they are vertical angles. And angle R is congruent to angle Y because They are alternate, N-A-T-E, alternate interior angles. Because two angles are equal, the triangles are similar. We'll say because two angles have equal measure. I don't like that either, because two angles are congruent. Let's say are congruent. The triangles are similar. That I could squeeze in there. Down to example number 3. All right, example number 3 is now adding some algebra to it. So it says solve problems involving similar triangles. They're asking you to know that the sum of the 3 angles of the triangle is going to equal 180, okay? If they give you a straight line, that also equals 180. So the first one says find the value for x. So because we know that this is 2x and this is 1x, we could say those two together equal 180. So 3x equals 180, which would make x equal 60, because you would divide by 3 in order to get 60. Okay, the second question says find the value of y. Well, you know that this is a vertical angle. They match. So this is 60 degrees right there. Okay, that's where that 60 comes from. And then we can say that 84, if you take a look at these triangles, this is 60, right? 84 and 84 are similar. So A is 84 degrees. So now, I'm sorry, congruent, not similar. So now we can say 84 plus 3y plus that 60 all equals 180, okay? They told us in the directions that ABC and EDC are similar, okay? So I already know that I can use this unit or this measure for angle A, because if I flip it over, it's going to be reflected and then dilated. Those are my translations that prove that these two are similar. They told us in the directions. If they don't tell you in the directions, you cannot assume that these two angles are equal. So then you would do the algebra. You're going to combine 84 and 60, and then subtract that from 180. That will give you 36. And then you would divide by 3 to get y equals 12. Okay, let's look at the try it. Okay, I need paper because this is not enough room for me to do that. Okay, so I'm going to go ahead and try and do it above it so that I can show you all the work that's involved. And I'm going to label try it, page 373. Okay, it says find the value of x for the two triangles if the two triangles are similar. So they're telling you that these triangles are similar. That little box right there means that that degrees is 90. Okay, that's a universal mathematical symbol. So I know that this is 90 degrees. Now the thing is, they want me to find x. The only way I know to find x is to figure out all 3 of these angles and set them equal to 180. But I don't know this angle yet, right? So what I need to do is figure out these 2 angles. If I label this y and this one y, because I know these are similar, so if I figure out these angle measures, then I know what that one is, and I know what that one is, right? So I know that y plus 90 is going to equal 180. I can label these y because this little symbol right here means that they're the same value. They're the same degrees. So that tells me that 2y plus 90 equals 180. Let's do a little algebra. And we're going to subtract 90 from both sides. That cancels and leaves me with 2y equals 90. Divide by 2. And y is going to equal 45 degrees. Okay, so that means this angle right here is 45, and this angle over here is 45. Now I know that 15x is going to be the same measure as 45 degrees because they told me my triangles are similar. So now I'm going to take 15x and set that equal to 45. Okay? All I have to do is divide by 15 to figure out that x is equal to 3. But I'm not done yet because it says explain. Okay? Page 373, explain. So, first you find the value. I'm just writing what I did. First, find the value of the two angles that are equal. Then set 15x equal to that value. Which is 45. You solve for x. Then solve for x. X equals 3. Correct? Let me double check. Yep. This is your explanation. You guys did a great job. Thanks for hanging in there. We'll talk more in class.